Hi, I'm Singaravelu and I have my PhD in chemistry from Michigan Technological University, USA. And I own this YouTube channel, Teach Me. And in this session, we are going to see the structure of atom and the introduction. For this video, I have referenced and taken my inspiration from various books. That is Class 11 CBSE book Chemistry Volume 1 from NCERT and Chem Libre text, which is an open source chemistry online resource, and American Chemical Society for a colorful periodic table, and always Wikipedia is a universal reference guide for any topic on any subject. With that, let's get into the chapter structure of atom. Atom was perceived as a undivisible fundamental particle that makes up the matter in the universe. That was the notion by Democritus around 400 BC. Whereas a Tamil poet named Avvaya around 12th century postulated that it is a divisible, which is the fundamental particle that makes up the matter, and it is called as Anu in Tamil. While there are several other studies or hypotheses or postulates by various scientists or philosophers at that stage or throughout the course of history, it was John Dalton who gave a some basis or foundation for the atoms, which is a fundamental building block of any matter, in his publication called A New System of Chemical Philosophy. And that model was called Solid Sphere Model of Atom. By the time no subatomic particles were discovered, and it was thought it is undivisible even by John Dalton around 1808. So, in the structure of atom, there were developments happening in the scientific community, and it was J.J. Thomson's work in cathode ray tube which led him to discover the electrons and propose a model called plum pudding model of atom. And with his experimental setup, he was able to calculate the mass to charge ratio as well. Based on the setup, he had two electrodes inside a partially vacuum sealed glass tube to which a higher voltage was applied between the electrodes anode and cathode. The cathode rays emanating from cathode surface traveled past the perforated anode and hit the surface of the vacuum tube, which was coated with a fluorescent material. These rays were identified as negatively charged by performing various control experiments like applying magnetic field and applying electric field in perpendicular to each other. In that sense, it was clear that the charge of these rays emanating from the cathode was indeed negative in charge as it get deflected by the positive polarity of electrodes or electric field applied in perpendicular to the direction of the cathode ray beam traveled. So based on that, he discovered and identified that those particles were indeed negatively charged, and they were called as electrons. And the electrons was identified in the atom, a first subatomic particle discovered in the history of atom, or in the study of structure of atom. So this one, he thought, is around distributed in the positively charged atom, and that model is called plum pudding model of atom. And later Goldstein, who performed a similar experiment but with a slight modification, wherein he used various gases, not just one gas. He used several gases and modified the perforated cathode instead of an anode, in contrast to the J.J. Thomson's work. So now he applied a similar higher voltage in the order of 1000 kilowatts to 5 kilowatts, and then the canal rays that were called canal rays had a positively charged nature, which is in total contrast or opposite to the behavior or the properties of negatively charged cathode rays observed by J.J. Thomson. So this led him to understand that, or it could be the positively charged nucleus, or in case of hydrogen, if it was the gas, it would be simply proton. But it wasn't very well distinguished, but it is what he observed in the case of hydrogen is proton. Later, Rutherford, who did his experiment with the gold foil, wherein the foil was bombarded with the alpha particles. Alpha particles are nothing but positively charged helium nucleus. The helium gas, when it is ionized, it loses both the electron to become helium 2 plus, which is called alpha particle. These alpha particles, having a positively charged, carrying a positive charge, were emanated or coming out of the alpha source, were directed towards the gold foil, a thin foil of around a few nanometers or few tens of nanometer in thickness. And the observations of his study were led him to conclude that the atom was indeed not positively charged sphere in which the electrons are distributed. It was indeed concentrated in the center. How? He had the photoluminescent thin film which was surrounding the gold foil. So the bombarded alpha particles, about most of them, passed through the thin film of gold foil, a thin foil of gold, and some of them got scattered. And by observing the angle at which it got scattered, he identified that the atom was indeed mostly an empty space, and the center was concentrated with the nucleus, and the electrons were orbiting around or revolving around the central positively charged nucleus. Why? About 5% of them, or even less than that, were directly bounced back or almost got deflected by an angle of 180-degree from the source of incidence. So that led him to propose a nuclear model of atom. And electron is represented by E superscript negative, and it is a negatively charged particle. Neutron was neutral in charge, and it wasn't discovered yet by these experiments until now. proton was a positively charged particle denoted as P superscript plus. So here is a question we would like to uh, evaluate our understanding for the concepts that we have learned until now. Question 1. The word atom derived from a Greek word atomio, meaning uncuttable or non-divisible. Given a chance to rename the terminology, what would you do? And with your understanding from this introduction, the discovery of subatomic particles, what do you think of atom? Is it non-divisible or divisible? So the question 1 has two sub-questions. The first one, what would you do when you are given a chance to rename the atom or the word atom, right? Although the word means undivisible, but now with the discovery of subatomic particles, we know that it is further divisible into nucleus, the positively charged center, and then the electrons are distributed around it according to the Thomson's model, or the one that I have drawn here is Rutherford's model. According to the Thomson model, it is a positively charged sphere in which the electrons is distributed all around it, right? But that was the notion. So what would you do given a chance? Would you rename it or no? That is the sub question 1. And in the sub question 2, what do you think of atom? Is it non-divisible or divisible? So you have to answer two questions out of the choices that were given: A, B, C, and D. So let's read what the choice A means. It says for the 1, it says yes, I will rename it. 2, it is non-divisible. Absolutely, this is not the right answer because we know that the atoms are divisible. So let's strike it out. That's not the right one. And second one, I will see if you have a lengthy answer, then you could look for the second one, which says what it says, uncuttable. So irrespective of whatever be the answer is, the choice for second sub question is not correct. So you could strike off that one. Similarly, when you have lengthy passages, you read through this one. It says non-divisible. No, atoms are divisible. And in here, it says divisible. And the first choice, it's okay. I don't know. But that's the right answer you select for the question. And the second question here is a new system of chemical philosophy by Dalton is a comprehensive knowledge about chemical reactions. Which of the following statements about the theory are incorrect? So you have to find out which of these statements are incorrect. Before we even read these answers, let us quickly recollect your memory from the chapter 1, which says law of conservation of mass, which is matter can neither be created nor destroyed, proposed by Antoine Lavoisier. And the law of definite proportions, which was given by I think Proust, who said that elements combine in certain proportions, and when you take any two different compounds from obtained from two different sources, irrespective of the source, they will have the same proportion. For example, in the case of cupric carbonate, which is denoted as CuCO3, a natural sample and a synthetic sample were took, and it was identified that they all have same percentage of copper, oxygen and carbon. So which clearly gives the evidence that they have elements combined in a certain proportion and it is same. All right, let's see the law of multiple proportions and what it means. It says that two elements combine to form more than one compound. How? For example, let's say how H2O is formed. H2 is a hydrogen gas and it is 2 gram, and now we take the monoatomic oxygen in here uh, and which will weigh 16 gram, and combination of these two will yield H2O that will weigh 18 gram, and that's the reaction 1. And now we are going to this reaction 2, in which the first element or the first reactant, to be more precise, is kept in the 2 grams. It's the same as in the previous one, and the second one is varied. Oxygen, instead of O, now it is O2, which is a diatomic gas which will weigh 32 gram, and the reaction between these two will give hydrogen peroxide H2O2, which will weigh 34 gram, right? So now if we take the hydrogen which is fixed, and if we find the ratio of the oxygen which is given as 16 is to 32, in the first reaction it is 16 and in the second reaction it is 32, so that is in the simple integer 1 is to 2, and that's what law of multiple proportion says. When two elements combine to form more than one compound, in the first one it is H2O, water, and in the second one it is hydrogen peroxide. When it forms more than one compound, the ratio of the second element, the one that is varied, will be in the mass ratio of that second element would be in the simple integer ratio, like 16 is to 32, which is 1 is to 2. That is what a law of multiple proportion says. And the fourth one, which deals about the gases, was given by Gay Lussac, and what it says is 100 ml of hydrogen combines. Here is an example. This one is an example, and combines with the 50 ml of oxygen, which is half the volume of the hydrogen, will give how much volume of H2O. And if you are familiar with the stoichiometric notions, it would be easier. Here you have the stoichiometric coefficient for hydrogen as 1 in this case, and for oxygen it is half, 1 by 2. And while doing so, you will have a perfectly balanced chemical reaction. So 2 hydrogen, half O2 becomes 1 O, and that is for water, which is 1 mole of water, which is the equivalent to the same of 1 mole of hydrogen. Why? That is Avogadro's law. You have to recollect that to answer that question, or to understand it better. What the Avogadro's law says is, at same temperature and pressure, the volume of all gases would be equal. The volumes of all gases will be equal. And if they are all equal, if the volume of all different gases are equal, then they will have equal number of molecules, and that's what Avogadro's law states. Different gases at same temperature and pressure having equal volume will have equal number of molecules or same number of molecules. So having understood this concept from Avogadro's law, now we should be able to clearly say by balancing the stoichiometric coefficients for the reaction between 100 ml of hydrogen with 50 ml of oxygen, which is, it's happening at the same temperature and pressure, right? So in that case, if we have one molecule or 1 mole of hydrogen and then it combines with half mole of oxygen to give 1 mole or 1 molecule of water are equal to the stoichiometric coefficient of hydrogen, so which is 100. So in this case, the volume of product is 100 ml. So this is what Gay-Lussac's law of gaseous volume means. And now Dalton's atomic theory. It says that atoms make up matter, and those atoms were undivisible. Atoms of same element are identical irrespective of where they were found, for example, in different compounds. If it is from the same element and they were identical, and that's what his concept is. And two other, and the third one, which says that compounds were formed when two elements are reacting or combining in a fixed ratios. Fixed ratios are formed when two elements combine in fixed ratio. And the fourth one, from the Dalton's atomic theory, is the the reaction between the chemicals, or chemical reaction, is nothing but the rearrangement of atoms to form or combine in definite or multiple proportions to form a new compound. So that was his fourth one. So having understood that, let's now read through the choices. A. Dalton's theory is inconsistent with law of conservation of mass, law of definite proportions, and law of multiple proportions. That statement is a true statement, right? So, but we were asked to find out which of the statements are incorrect. So we don't need to select A. Now let's look into B. Dalton's theory can explain why surfaces get electrified or charged when glass or ebonite rubbed with silk or fur. He never discussed about any such phenomena. So this is not a correct statement, which is not a correct statement. Maybe we note it as false. So we have to select this one as one of our answer that was given in choices A, B, or C and D. These are all the choices that we have given, right? We have to select our answer from this one. And C, statement C says Dalton's theory can explain why and how atoms combine. Although he said that atoms, the chemical reaction is nothing but a rearrangement of atoms, but he never explained it why it happens or how it happens. So this statement is also false, or which is incorrect according to us. This question. Dalton's theory can explain volume changes of gaseous reactants. You recollect from our discussion that it was Gay-Lussac's law of volumes, not Dalton's theory, which deals about the changes, volume changes of gaseous reactants. The volume changes of gaseous reactant is also similar to the law of definite proportions for solid state reactants, whereas the Gay-Lussac's law is similar to that one but for gases, or law of definite proportions for gaseous reactants. So what we understood is statement B, C and D were the incorrect statement for us, which we have to select, and this is a true statement. So we have to see B, C and D as an option which is given in choice C. So our answer is C, B, C and D. Thank you very much for your attention. And again, I thank all the reference materials, NCERT book, CBSE grade 11 chemistry volume 1 book, Chem Library text, American Chemical Society and Wikipedia. Thank you.